So today we're looking at something that is literally Pythagorean theorem on steroids. You learn Pythagorean theorem in grade 8, 9, 10, and 11. Right? Now, what you need to understand is instead of having patterns that change, remember you'd start with a squared equals b squared plus c squared, and then in order to find b, you always had to say b squared is equal to a squared minus c squared and things like that. That does not happen with this equation that we're going to be taking a look at today. The pattern of these things are going to stay the same always. How do you know we understand? Well, you'll notice that an angle with two sides around it is going to be a cosine law problem. Now, with that angle, there's an opposite side, and that opposite side is what we look for. So what I want you to imagine is you have a triangle with an angle. So let's say it's 35 degrees. And then you have two sides that are directly around it. So maybe one is 10 meters and the other one is, say, 15 meters. With an angle between them. So basically you have a side and a side that are touching with an angle between them. And what we are looking for is this thing, x. And that value of x is always going to be calculated in a certain way. Now, that's one way of using cosine law. Another way of using cosine law is this. Imagine that we're looking at a triangle that has all sides but no angles. Obviously, you can't use sine sausage because, well, there are no angles available. This is the time when we can use cosine law to find, say, this side, this angle, theta. Now, let's go over the problems. So, cosine law, like I said before, it's Pythagorean theorem on steroids, and it works for all triangles. And there are two versions of the formula, and we're going to go and look at them. There is a version just for sides, and then there's a version just for angles. I'm going to go over the equations for the sides first, and then I will show you the basic pattern for finding an angle. Now, finding an angle in that case is going to end up looking at some form of cosine, and you already know how to calculate that. Here we go. For the sides of this triangle that we have here, ABC, here's side A, here's side A, here's side B, here's side C. This is what a squared is. It's literally a squared equals b squared plus c squared minus 2bc cosine of the angle between them, also known as a. So basically, if you think about it, you've got a squared equals one side squared, the other side squared, minus 2 times the first side, and the second side cosine of the angle between them. And that helps us find it. And then at the very end, we just square root the result of everything that we have here to get a by itself. Now, this is b. So now, if you look at it, b is just b squared equals a squared plus c squared minus 2ac cosine of b. So the cosine law for b is very similar to a in the sense that we use the two other sides and then minus twice the other side's cosine of the angle between them, which is just big B. So try to figure out what side C would be, guys. And you guessed it, you got the correct answer. Now, let's talk about the angle formula for these. So if I was looking for the angle A, we would actually take a look at this equation here, and you notice how it has cosine A. So what we would do is we'd rearrange the equation and it would look something similar to this. So for the angle A, we would start off with cos A equals b squared plus c squared minus a squared divided by 2bc. Then, in order to solve for cosine A, we have to find the numbers that this big calculation is. So imagine that you did the problem. What you would do is you would do the top first, divide by the bottom next. Now, when you divide by the bottom, I would tell you right away, just divide by the bracket of 2 times b times c in order to get your answer. It will save you time. And now, let's go on for angle B. And this is what we get for our B value calculation. So for B, you take the other two sides, add them together, add the squares together, and subtract the B side squared. Then, once you've done that, divide by 2AC. And you'll notice, like I said, I would divide by the bracket of 2 times A times C. Now, for the final value of C, for cosine of C, we're going to get, and we get this. Now, we're going to use the cosine law to find these appropriate sides. So, for the first problem, you'll notice that we have two sides with an angle between them. And we're looking for the opposite side of the angle. Now, this automatically tells us this configuration here, side with an angle and a side, and an unknown angle directly across, unknown side directly across it, tells us that this is cosine. In order to find it, we're going to use the pattern that we had up here to find it. So the side that we're looking for is x squared. So I'm actually going to write that out. So I got x squared equals, well, one side squared is 18 squared plus 23.4 squared minus 2 times 18 times 23.4 times cosine of the angle between them, and that happens to be 58 degrees. And now what you have to do is you actually have to punch this whole equation into your calculator. Do it from left to right accordingly. If you have an older calculator, start with cosine of 58 degrees. Start with cosine of 58 and then multiply this part out. Notice the minus 2. And then add this squared and this squared. So the 18 squared and the 23.4 squared. Now, once you punch this whole line into your calculator, you're going to get the following. We get this. X squared is equal to all of this. Now, you'll notice that when I was doing the calculation for the length for this part here, all I did was punch in 2 times 18 times 23.4 times whatever this is and put it in this bracket. Now, the reason why I stopped at the 8,8 was the next number after the 8,8 was a 1, a 2, or a 3. And what that does is the farther down the decimal calculator I go, the ones that come with either a 0 or a 1 past these deep numbers in our decimal actually will make us have a very close number to what we need. So now I'm going to put this all together and we get a value, which is this. So once we do our calculations, we get x squared is equal to approximately 425.156, and then there's a 0 after this, so I can stop right there. So now, in order to get x by itself, we have to square root 425.156, and we get the following number. 20.6 centimeters, which is our actual length of x. So remember the hint. When looking for decimals to stop at, stop recording. Look for 0, 1, or 2 after a really high decimal such as 8, 9, or 7. And you're good to go. You can do that with 6 as well. Now let's move on to question B. We're going to do the same thing that we did just here, except this time we're going to do this in one shot. Now this problem here, we're looking for y. So we start by writing y is equal to, y squared is equal to, the two other sides are 5.3 squared plus 8.3 squared minus 2 times 5.3 times 8.2 cosine of 130 degrees. Now we'll do the problem again, and we'll do it with all the steps that we did. Now you can punch this in one shot, but I'm going to go through each step individually. And doing the calculations for each of those things, remember with this last part here, I want you to put it in brackets and keep the minus sign, and then just type this exactly as you see it in your calculator to get the following. Y squared equaling 151.20. Now, in order to get y by itself, we have to square root. So y is equal to the square root of 151.20, which gives us 12.3 for our answer. And we're good to go. So remember, we talked about finding the sides of anything. So imagine this is the angle A that we're looking for, right? The angles around, the sides around them are 12 and 24. If you want to make your work easy, you can easily just label all your corners, label all your sides, and then refer to the equations that we had before. Remember, the basic form of the equation is cosine of A is equal to B squared plus C squared minus A squared divided by 2BC. So that's basically cosine of A. Cosine of any angle is going to be the two sides that surround the angle added together minus the corresponding side to that angle. So for this side, the corresponding side to the angle is 18. So that means 12 and 24 are the sides that are right beside A. So when we calculate A, we write cosine of A is equal to, well, 12 squared plus 24 squared. So those are the sides that surround the angle A. And then minus the side of A, which is 18 squared. And then we divide by 2 times the sides that are around the angle A, which is 12 and 18. Now, what I want you to do when you do these calculations is calculate the top, calculate the bottom, and then divide this stuff out, and then we find the angle A by taking the inverse of whatever that decimal comes out from this and this dividing each other. So for the top, we get the following. Cosine of A is going to be 396. And for the bottom, when you multiply 2 times 12 times 18, you're going to get 432. So now you can either divide out 396 over 432, or you'd be a boss, and what you do is you calculate the cosine inverse, and then you put that entire fraction in a bracket, and you just write 396 divided by 432, and we get our answer. And we end up with A equaling approximately 24 degrees. Okay, now I want you to try this next one here. Remember, the cosine of the angle we're looking for has got to be the two sides surrounding it added together minus the top bit added together divided by 2 times the two sides multiplied together. So you're going to get something that looks like this. Okay, 11.5 squared plus 8 squared minus 16.4 squared divided by 2 times 11.5 times 8. Now, you just have to memorize the pattern in order to find the angle. Expanding the top part of that fraction, we're going to get the top portion to be negative 72.71, and now we'll calculate the bottom. And we end up with 184 for the bottom. To find the angle theta, all you're going to do is the final step. Theta equals cosine inverse of negative 72.71 divided by 184. And you'll notice I put all of that in brackets, and we get the following answer. And we end up with theta equaling 113 degrees. So remember, to find the angle using cosine law, remember what you're going to do is you're going to take the square of the two sides, always start with the two sides that are around the angle, and then subtract the last side squared, and then divide by 2 times those two sides that surrounded it. Take a moment and bask in that question's glory. Now, what I want you to do is the following for your homework. Now, for your homework, I want you to try today in class before you leave this question. Page 47, number 5. Good luck. It's based on the 2 types of questions that we found, which were one where we found the side, and then one where we were finding the angle. Good luck.